Hello students, in this video we are going to see that how we can calculate particle size of nanoparticles using your XRD data. So for this purpose we use an equation which is called as Scherrer equation, which is actually tau is equal to k lambda divided by beta cos theta. So we are going to see that what are these parameters and how we can obtain them through your XRD spectrum. So tau is basically the particle size that you are going to calculate for your nanoparticles. Lambda here is actually the wavelength of X-rays that is used to irradiate your nanoparticles to get your XRD spectrum. And it is fixed and constant. It is also given in your XRD data in the Excel file. Beta is the line broadening at half maximum of the peaks. That is, for example, if you have this is the XRD spectrum of your sample, then the width of the peak at this position is called as the beta. That is the half maximum of the peak. The width of the peak at half maximum is the beta of this line. And this is given for all the peaks of your samples. And it is also given in your data along with your XRD spectrum. Theta is actually the Bragg angle, or you can also say it is the position of your peak. So here you can see on the x-axis we have angle which is plotted in the form of 2 theta. So the position of these peaks is actually given in the form of 2 theta, and you have to divide the 2 theta by 2 to get the value of theta for putting it into this equation. Lastly, we have the k, which is the shape vector of the nanoparticles, and its value is constant and it is close to 1 for the spherical particles. If the particles are not spherical, then its values is different a little bit, and you can find it out on the internet depending upon the shape of your particles. So the first thing you do in finding out the particle size of your nanoparticles is that you find out the value of theta, which is determined through the position of the sharpest peak in your XRD. For example, this one is located at around 25, which is 2 theta value, and I will divide it by 2 to get the value of theta, which can be placed in this equation here. Beta is also given in your XRD data. You do not need to find it out manually, although you can also find it out manually, but it is also given in the form of Excel sheet with your XRD data. So you will find out the value of beta only for the sharpest peak in order to find out the particle size and put it in this equation. Here you have lambda. Lambda is actually the wavelength of the X-rays that is used to determine your XRD spectrum. It is usually 1.54 angstrom, which you can put here. Now, one thing you need to keep in mind is that you need to use SI units throughout so that you have the correct results. The SI units of theta is radians, it's not theta, it's radians. So you may need to convert it into radians, and lambda is also should be in the SI units. So after finding out the particle size, you may convert it into the nanometer size, because usually the particle size is represented in the form of nanometers. So this is how you can calculate the particle size of nanoparticles using your XRD data. Thank you.